Question 5, we're going to start by completing the square. And remember, completing the square, we always want to find half of that number there. So we've got x minus 3 over 2 all squared. What else are we going to get? We've also got to take away this number squared. So 3 squared 9, 2 squared 4. And we've also got to add 5. But as we're talking about quarters, 5 is the same as 20 quarters, isn't it? So what does this tidy up to give? It gives us x minus 3 over 2 all squared plus 11 over 4. So the line of symmetry with this thing here, well, it's a quadratic graph, isn't it? Its minimum point here is going to be at 3 over 2, 11 over 4. So its line of symmetry straight down there at x equals 3 over 2. Actually, the next bit's got nothing to do with it, has it? The next bit just says, when does this line meet this curve? So we've got to put these two things equal to each other. X squared minus 3x plus 5 equals x add 5. It's a quadratic. So we just put all the algebra all on the left-hand side. Taking away the x gives us minus 4x. Oh, taking away the 5, they're going to disappear. Makes the factorising easier, doesn't it? So we just got factorising of x and x take away 4. So we're going to cross when x is equal to 0. Oh, I knew that. X equals 0 is 0.8, isn't it? And also when x is equal to 4. Are we done, or do we want the coordinate? Find the coordinate. So let's find out the y value as well, just by throwing the 4 back in here. And so obviously we're going to get 9. So b is at the point 4, 9. Integral, we did differentiating in the last question. So integrating, the power goes up by 1, and we divide by the new power. The power goes up by 1, and we divide by the new power. The power goes up by 1, and we don't forget to put a plus c on the end. Last part then is all about finding this area. We want to try and find it in two ways, I guess, that we've got to try to think about. First of all, what's the area underneath this graph here? This area here would just be this integral from 0 to 4. So let's do that first of all. So we're trying to do x cubed over 3 minus 3x squared over 2 plus 5x between 0 and 4. And throwing the 4 in, that's giving us 64. You do need to know what 4 cubed is. Minus 4 squared is 16. 16 times 3 is 48. And we've got 20 there as well. That's putting the 4 in. Putting the 0 in is just going to be 0. So that's not too much of a problem. Working that out, I think I'm going to have to go into the fractions now then. 64 divided by 3, well, we know 63 divided by 3 is 21, don't we? That's 21, that's 24, isn't it? 24 at 20, I think I'm getting 17 and a third for that bit there. But that isn't the area we want. That's the area under the curve there. The bit we want is then going to be this trapezium. Take away this 17 and a third. So our trapezium here is, what was it? It was 5 high there, wasn't it? We know that's 9 high there, and this is 4 across, and the good old trapezium one. Half the sum of the parallel lines times the distance between them. That's how you find the area of a trapezium. Add these two together, that's 14, and halve it. Half of 14 is 7. Half the sum of the parallel lines times the distance between them. 7 times 4 is 28. So we've got to do 28, take away 17 and a third. Well, 28 take away 18 would be 10, wouldn't it? So we've got 10 and 2/3 as our final answer for the area there. Here's the mark scheme. 10 and 2/3. And here's the examiner's report.